All right. Oh, I think we're gonna go ahead and get started. Thank you all for Climate Assessment Day. Very exciting. But today is our South Central Regional session for our Climate Service Providers Academy. Thank you all for being here. We're sending a link to the agenda in the chat, but I'm going to go over it right here. So we are going to get really a wide understanding and introduction to South Central specific tools and data from SCIP, the South Central Impacts Planning Program, and the South Central Climate Adaptation Science Center. So we're going to be led through that by Dr. Vincent Brown and Dr. Sharon Howsam, and I will introduce them in a moment. But they are going to first start off the day with an overview of their service providers and tools. And then you all are going to get a chance to kind of discuss that and kind of reflect on what the instructors have talked about so far. Then we're going to go for a 10-minute break. And when we come back, we're going to get two case studies, one from Annie Vest and one from Barney Austin. That should be a really interesting case study about how they are using the tools and resources that you're learning about. Then you'll get another chance to break off into smaller groups and really discuss your own experience, and how that can apply to your future work. And then we're gonna wrap up and look forward into our next session. All right, so I am gonna start off by introducing our instructors today. And just as a reminder, when you aren't talking, if you could mute your mic just so that we don't have any background noise, I would appreciate that. So we have our two instructors today. Like I said, we have Dr. Vincent Brown from the Southern Climate Impacts Planning Program. Dr. Vincent Brown is SCIP's Climate Research Director and is located at the Louisiana State University. Dr. Brown is an assistant professor of research in the Department of Geography and Anthropology at LSU. He holds a PhD in geography from LSU, an MS in geography from the University of Tennessee, and a BS in geography from Salisbury University. His research interests include climatology, precipitation, climate change, and statistics. And his current research focuses on precipitation extremes, particularly in the Southeast United States. And we also have Dr. Sharon Howsam from the South Central Climate Adaptation Science Center. Dr. Sharon Howsam is the South Central Climate Adaptation Science Center's climate adaptation planner and research scientist. That is a big title, and you deserve it. Her professional practice and research focus on climate resilience strategies, climate justice, community-based and collaborative planning, tribal sovereignty, and the use of both Western science and indigenous knowledges in climate adaptation. Prior to joining the CASC, Sharon served as the planning program manager for the Pueblo of Laguna, where she initiated work on climate adaptation planning. She is an adjunct faculty in the Community and Regional Planning Department at the University of New Mexico. Sharon holds a Bachelor of Science with a double major in Biology and Art, a Master of Environmental Studies, and a PhD in Urban and Regional Planning. She lives between the Sandia Mountains and the Rio Grande on traditional southern Tiwa Pueblo land, currently known as Albuquerque, where she enjoys gardening, foraging for wild plants, canning and drying food, walking her dog, and hiking. So I'm very happy to introduce them both and to have them lead us in the next session.
Awesome. I guess I'll go ahead and get started. Thank you for that great introduction. Eliza. So as she just said, my name is Vincent Brown, and I am the Research Director of the Southern Climate Impacts Planning Program, or SCIP. I'm at Louisiana State University, or LSU, and we have some other members across, but I'll get into that in a second. Just as a reminder, SCIP is a National Oceanic and Atmospheric Administration, or NOAA-funded climate adaptation partnership, or CAP team. And we were started in 2008, and we serve the states of Arkansas, Louisiana, Oklahoma, and Texas. As I started saying, our team is unique because it's a partnership between a couple of universities. We have obviously LSU, where I'm at, University of Oklahoma in Norman. We also partner with Texas Sea Grant, Texas A&M, and recently Adaptation International, which I believe is in Austin, Texas, if I'm correct. But so basically what we do at SCIP and what our mission is succinctly, it's to help communities build resilience to weather and climate extremes now and in the future. And right now we are currently, we are currently in the middle of our fourth grant cycle. And we have, in this phase, we have 4 different topic areas. First, climate informed planning. As you can see, that cool little diagram. In that theme, we focus on effectively incorporating climate data information into planning. It's all about getting climate information data into the planning process. And the second one is developing governance and collaborative capacity. Again, that theme seeks to identify levers that communities or stakeholders can use to improve their response to weather and climate extremes. Think of things like finding economic solutions or fiscal funding options, or developing, helping building codes after an event happened. Third phase or theme is extreme events in a changing climate. That's the one that I work on prominently and at LSU, and that's all about researching the physical phenomena that affect our stakeholders in the region. Think tropical cyclone research, freezing events, extreme precipitation. And then lastly, the fourth theme is climate justice, huge focus area of us now. And it really seeks to address the disproportionate impacts of climate change and climate stressors on underrepresented populations, and just really ensuring that their voices are heard in decision-making process and all that good stuff. So that's just a brief overview of SCIP, and thank you.
And thank you also, Eliza, for the introduction, and appreciated the comment about the long title and deserving it. No one's ever actually said I deserve a long title before, so that was nice. So I am with the South Central Climate Adaptation Science Center, and the Climate Adaptation Science Centers are a national network of regional organizations. There are 9 regional organizations and 1 national CASC, and each of them are partnerships between the Department of the Interior, U.S. Geological Survey, a host university, and then other regional members that form a consortium. And in the case of the South Central CASC, we have the same host university that SCIP does, which is University of Oklahoma. And then a number of universities in our 4-state region. The regions do not overlap exactly. We have New Mexico, Texas, Oklahoma, and Louisiana. And we also have 2 tribal nations that are consortium members for the South Central CASC, the Chickasaw Nation and the Choctaw Nation in Oklahoma. The CASCs generally support federal and state agency needs for natural and cultural resource management, and also tribal government needs, especially those within the Department of the Interior for the federal agencies. The Bureau of Indian Affairs is also under the Department of the Interior, so some of our work with tribes is associated with that. Our focus is often on climate data itself and climate projections, and I'll talk more about that when I talk about the tools. But also, there's a lot of related work that the South Central CASC does. And I will jump into some of the challenges we have in the region just to start that off. One of the things about this region, particularly the South Central, is the wide variety of ecosystems that we have. And that's something important to recognize. Particularly within the CASC region, we go from New Mexico to Louisiana, in which there are very distinct ecosystems. And so we're looking at a wide range of change in climate throughout the entire region. Next slide. One of the opportunities, as we see it in our region, is the high number of federally recognized and also state recognized and not yet recognized tribes in the region. I think we have, I wanted to say we had 68 recognized tribes. This map may be showing both recognized and not recognized. Many of those are in Oklahoma and in New Mexico, but we also have some tribes in Louisiana and in Texas. And this is an opportunity because it gives us the chance to have these partnerships, have these consortium members, and really also think a lot about those interactions with sovereign governments and how those work, and have important conversations about both Western science and indigenous knowledges.
Great, thank you. Yeah, so I'll jump right in and start talking about some of the challenge that we face in our region, and this is specifically, I guess, my opinion of things. Like as I mentioned, we have a big team across multiple universities with different expertise. I just happen to be on the sort of physical science side. And one of the challenges that immediately comes to mind is disasters and the frequency of them and the diversity of hazards that we get. So here depicted on this slide are annual counts of billion-dollar disasters from 1980 to 2023, which 2023 is obviously still in progress. But the only caveat here is that this is for the states of Arkansas, Kansas, Louisiana, Mississippi, Oklahoma, and Texas. So if you take out, so it's not truly our region, but it includes Kansas and Mississippi, but sort of it tells the tale. Our region, communities in our region face.
I have your credit card, by the way.
Oh, somebody. Anyway, face drought, wildfires, floods, winter storm, deep freeze events like what happened in February 2020. What is being depicted is just the raw count of events. And I put an arrow over 2005. Because in 2005, obviously we had Hurricane Katrina, we had Hurricane Rita, and we had some other events that were some of the costliest disasters to ever impact the United States, let alone the region. So the raw counts don't do it justice. So can you go to the next slide, please? Yeah. So just in our region since 1980, we've had 244 individual billion-dollar disaster events. That's roughly 5.5 events per year, which, it's just whatever, it's kind of roll of the dice, whatever we see Mother Nature seems to throw at us in any given year. But in, financial terms, it's cost our region, again, the country, I guess, $889.5 billion. That's roughly $20 billion per year in disasters. And I mean, transitioning into how this challenge can be an opportunity for us in a region that is so heavily impacted by these events. We have a great opportunity to help communities, stakeholders, whoever it may be, improve and better prepare for these type of events. We can help fortify their plans, help them be better prepared, and also mitigate the adverse impacts of these events on them. So with that, I think I'm done talking about our challenges. Yeah, great. So I can step right into talking about some of the tools that we have at Skip. Here listed, we have 10 tools we have 8 tools on our website, and 2 of which are currently in development. The ones that are in development have the asterisk. I'm going to talk about one of them today. One of them I'm not really going to talk about. But anyway, so again, we have 8 tools on our website. The ones in red, we're going to go into a little deeper dive on, but I'll give a shout out to the other ones. The first one's a Southern Drought Tool. What that basically does is for the states in our region, by climate division, you can go in and it shows you the status of drought for those climate divisions. So for example, if you go to that tool right now and look at the state of Louisiana, you can take a look at the climate divisions, which are basically, if you can think of a climate division as just sort of a homogeneous region across the state where the topography and the elevation, all that kind of stuff is similar. We call them, homogeneous climate regions. Basically, it shows you what drought is like, derived from precipitation gauges in those regions. Simple planning tool, I'll skip because it's on the next slide. We have an average monthly temperature precipitation tool. You can go for a certain area or even a station, and it'll tell you on average what does climatology tell you the temperature and precipitation should be in that month. And then it compares that to the most recent month or months in the past. So for example, you can see, are we drier than normal this month? Are we wetter than normal? And so on. The Climate Graph tool does a very similar thing, but it's purely station based. For example, if you're close to an airport, you can punch in the airport code and it'll show you what typically happens over the course of a year for, say, precipitation. And then it'll tell you if you're above or below normal. We also have a tool called SurgeNet, which is the most comprehensive surge database in the world. Basically, you can go in and look at for certain storms. We use NOAA tides and currents data, as well as a bunch of newspaper and sort of informal sources, and we've compiled a data set of surge heights for a bunch of tropical cyclones. I think we have data going back 1900, so it's pretty comprehensive. And then we also have a live version of that. So as the storm's approaching the coast, let's say next season you have a tropical cyclone coming in the Gulf of Mexico, you can click on our SurgeNet Live tool and it'll show you live tide gauges changing as the storm progresses. The next two I'll skip because I'm going to talk about it more in detail. And then we also have a final one is a tool we're in development where we can, for any unique geographic area, for example, if you provided us with a shapefile, we could create unique time series for you going back to 1951 of any temperature metrics, so maximum, minimum, average temperature, and precipitation. So this is a unique tool that we're developing where, again, you can provide us with some sort of shapefile or geographic area, and then it spits out, there's a lot going on behind the scenes, but it spits out a unique time series for you for that area. Next slide, please. Great. So the first tool I'm going to talk about is our simple planning tool. I'm excited to announce right now, the simple planning tool is a static document, but we're actually in the process of creating a website for it. So in the future, you'll be able to go to the website, kind of flip through it. It'll be updated as, probably as the tools change that are in it. But right now it's just a static document. But what the simple planning tool is, and the whole goal of it is to help for how to use a wide array of different weather and climate tools. So for example, if you're interested in maybe heat and cold extremes, or you want to look at historical occurrences of tornadoes or lightning, or how lightning or tornadoes may change in the future, you can go into this document, this simple planning tool, and there you go under that specific hazard type, and it will show you all the available, vetted tools that exist and show you how to use them. So for example, if you're saying, I want to find a record of the lowest station temperature near me, in there, you would go to temperature and you'd find, select the tool that you think sounds right for your needs, and it'll tell you step by step how to use that tool. So it's really good for just if you don't really know where to start, or you have certain hazards that you're interested in, it's a good place to start to go into and sort of show you how to navigate that this sort of arena. And again, we have them tailored to each state in our region. This one is just for Louisiana that I'm showing, but we have from Texas, Oklahoma, Arkansas, and Louisiana. Next one, please. Perfect. Historical climate trends tool, another really cool tool that I use quite frequently. Again, this tool is for sort of geographical areas. It's not, and it's really for either using a whole state or these climate regions, climate divisions like I was talking about. So for example, in the top right, you can see the different climate divisions in Louisiana. But basically what it does, it will display monthly, seasonal, or annual trends in precipitation or temperature for these sort of larger areas. And it can answer questions like, is there a trend in the average temperatures in June? Was the precipitation last October abnormally dry? So what you can see here on this figure on the bottom, I plotted for Division 6, which is this sort of, it's the one that I'm in, the East Baton Rouge Parish. So for this region, it looks at precipitation patterns going back from 1895 to present. And you can see, so normal or sort of the baseline is 0 here, or 3.5 inches going across the middle. But you can see last October, we were super, super dry. I think it only rained maybe one day, and that's reflected in this chart here. So it's a great tool to show long-term sort of aerial average time series of precipitation and temperature. Next slide, please. Perfect. And this is a tool that we just, we sort of revamped and expanded. It's called the Temperature Trends Dashboard. And what this one does is it's for stations, some of the best high quality stations we have in our region. It shows unique temperature time series at stations across our region. So a scenario where you might use this tool is if you're looking for, let's say you're in Baton Rouge or you're in somewhere in Texas, and there's one of these sites by you. You can see on this graphic to the left shows you the sites, the individual stations that we have in our database. We have 30 in Louisiana. But if you're looking for, say, the number of days annually where the temperature was above 90 degrees or 100, or if you're interested in the trend or just the counts of number of days below 40 or 20 degrees, you can go in and click on these stations, and it'll provide you with the CSV actual data output, but it will also display the a linear regression, just a linear trend in whatever variable you're interested in. So say you want to look at the number of days above 90 for this station, you click, and it will display a graphic just like you see on the right there. And there's a lot of documentation on it, which stations were included, and what the trend shows. So for example, one of the cool things is if you have a solid line, like you can see on that the bottom one, which I believe is number of days where the low temperature did not get above 75, which is that bottom orange line. If the line is solid, then it's statistically significant at the 0.05 level, so it's a significant trend. And if you have a dotted line, then it was not significant. But again, it's just a cool tool where you can produce very unique time series for certain stations across our region. And there's a bunch more different metrics. I just mentioned a couple. But cool. So this is the last tool I wanted to talk about. And I really wanted to highlight this one. I'll try to go quick because this tool was developed with a partnership with a private company. So that private company is called Applied Weather Associates, or AWA. They do a lot of rainfall event reconstruction, specifically for probable maximum precipitation. That's used in things like dam safety. So they need to know how much it's going to rain in certain areas and how to design the dam. But basically what AWA has is an algorithm or a tool called SPAS, or the Storm Precipitation Analysis System. And what this tool does is it produces, it reconstructs rainfall events at a very high one square kilometer resolution, set spatially and then temporally at the 5-minute level. It incorporates gauge data, radar, climatological base maps, elevation, all the things you want to account for when you're reconstructing rainfall. So as you can see here on this graphic on the right, this is how SPAS recreated the August 2016 flood event that hit Baton Rouge. And what SPAS outputs is something called a depth area duration table, which I'm going to go into here in a second. Mass curves, which basically shows for a certain location how much rainfall over time. And then isohedrals, which is just a fancy way of saying plotting the precipitation like you see on the bottom right graphic there. So next slide, please. Basically, just want to give you a quick overview of what depth area duration is and why it's important and how we've turned it into a tool. But basically what depth area duration is it enables you to objectively characterize rainfall or precipitation from a storm. And if you think about it, it makes sense, because if you just use a bunch of rainfall gauges or even just radar, it's very, very hard with only those sources to accurately and objectively sort of map or plot the aerial extent of rainfall and the magnitude as well. And I have two sort of graphics here showing this. So imagine on the left, you have a highly localized storm, maybe only a few gauges got a lot of rainfall. So it's very acute. It was a high intensity event over a very short area. Well, how do you compare that to a more widespread rainfall event like you see on the right, where there was a lot of gauges that got a lot of rainfall? There's no real easy way to say or compare the storm on the left to the storm on the right. So how do we do that? Next slide, please. We use something called depth area duration. And what depth area duration does, and on the bottom here, it's the graphical representation, but the way I find it most useful is looking at a table, which is on the next slide. But basically, on your x-axis here, you have the maximum depth of precipitation, so how many inches fell, and on your y-axis, you have over certain area sizes. And then the individual lines represent the temporal piece. So for example, if you look at the blue line there, it shows you over the 24-hour period how much rainfall over a certain area size and the depth. So for example, for this very short duration event, roughly, if you look at the 24-hour line, that blue line, roughly 6.75 inches of rain fell over 24 hours at 1,000 square miles. So that's, again, that short event. Look at the widespread storm. You can see the difference, how these lines they don't drop off as quickly. So for our larger area event, again, look at that blue line, that 24-hour line, we got over 12 inches of rain in 24 hours at that same 1,000 square mile area size. So it just basically shows us, it gives us a good way to compare rainfall events. So if you go to the next slide, please. Here's a graphical representation of what happened. So basically, again, we reconstruct the rainfall event, and every single 1 square kilometer pixel in the domain of the rainfall event has a mass curve, which is depicted at the bottom. On the x-axis is time, on the y-axis is accumulated rainfall. And basically what we do is for every pixel in the storm domain, we then create the DAD table. And that's what you see on the right there. So the way you interpret the DAD table is, for example, over 1 square kilometer, over 1 hour, 107 millimeters of rainfall fell. That's that first top left bin. So what you can do then is for any area size over any duration, you can go in and look at the depth of rainfall that occurred, and then you can compare that to other storms. So go to the next slide, please. So we have in our database 806 unique locations that have come from 548 different storms. The earliest ones from 1819 all the way up to 2023. And this is the distribution of all of those events across the country. And these events, I like to think of these events of sort of the biggest and baddest rainfall events that have occurred. These aren't just sort of random events that happen every other day. These are some big events. Think of like Hurricane Harvey's in here. The August 2016 rainfall event is in here. They're currently finishing up what just happened in Fort Lauderdale, the Ellicott City events. All of these big bad, if you can think of a big bad rain event, I can almost guarantee you that it's in here. So go to the next slide, please. So what's the point of having all these storms in the database? Well, you can go in and you can query and compare different rainfall events. You can go in for a certain area and figure out what was sort of the biggest and baddest rainfall event in your area. How does it compare to other rainfall events? And for example, if you're a watershed manager, what was the 100 square mile 1 hour event? How much rain did it produce over that? Next slide, please. And this is a cool depiction. So for example, this is showing what was the greatest 1 hour rainfall over 100 square miles in the entire database. And you can see the points are different storms within certain geographical zones. So you can so maybe you're in the South Central zone, you can just select South Central storms. You can find out how much rainfall over certain depths and durations occurred that might be useful for you. Next slide, please. I think it's my last slide. And this is how this database has really become useful. For example, everybody was really, really interested in Hurricane Harvey and what it did. And we were able to do some research and figure out that, theoretically, there's no reason why Hurricane Harvey, which happened in Houston and Beaumont, why that storm couldn't happen over southern Louisiana. So some stakeholders in southern Louisiana, some water utilities, I know we're working with the Sewage and Water Board of New Orleans, the Water Institute of the Gulf, they were interested in that footprint of rainfall. And so what we did is we transpositioned Harvey's rainfall and centered it over Orleans Parish. And then we provided that information to them, those grids, so they can put in their hydrologic models. And basically what we found is that if Hurricane Harvey was centered over Orleans Parish, the whole parish, all of Orleans Parish would have received over 41 inches of rain in just 3 days. And over 5 days, they would have gotten just about 48 inches of rain over 5 days. So what you're seeing on the right is the depiction of what would have happened if Harvey fell right over New Orleans. And these are sort of, things we can do with this database. So with that, I'll shut up. Thank you, guys. Yeah.
Awesome. Thank you. And just a reminder, if you have any questions for Vincent or Sharon as she continues her presentation, please feel free to put them in the chat, and we will have time for a little Q&A later in the session. And I will pass it back to Sharon.
Thanks, Eliza. And I'm sorry to be off video. I got a pop-up saying my internet was unstable, so hopefully it will work for this presentation. So the South Central Climate Adaptation Science Center does not necessarily have cool tools like SCIP does that are online, but we have a number of resources that we can provide, and also staff that can help support work on specific projects. One of the main resources that we have is through our partnership with the USGS in the Department of the Interior. And USGS, US Geological Survey, provides funding for research related to climate change. And that funding goes to researchers who are within the consortium institutions. But also sometimes that funding goes to the CASC itself. The CASC is the host institution, and the staff there are eligible to apply for and obtain that funding as well. And folks in the CASC are often doing climatology and meteorology and social sciences. I'm on the social science side myself. Some of the other work and research that is being done in-house in the CASC relates to the natural and cultural resource management. There's a paper that is in review now on freshwater harmful algal blooms, and also a literature review on climate impact and adaptation measures for Douglas fir in New Mexico and Texas, which is really the southern end of Rocky Mountain Douglas firs range. Okay, next slide. Online, we have a lot of resources that, and generally in the form of maps, that are depicting the South Central CASC's climate projections. So a lot of SCIP's work is looking at climate trends, and some of the CASC's work is looking at the future climate projections. We have low and high emission scenarios, and also mid-century and end-of-century projections. For temperature, the maps have annual average high temp, days greater than 100, number of heat waves, and annual average low temperature, and also the days the low temperature is below freezing. Some of the research scientists, and also we have climate adaptation specialists. You can kind of think of these as extension agents who are on CASC staff, and they can help with the downscaling of those climate projections. So getting down to a more granular level that might benefit communities that you're working with, whether those are cities, tribes, or counties. Next slide. We also have similar data, high and low emission scenarios, mid-century and end of century for precipitation. So annual average rain or snow, number of days with rain, 1 day maximum and 5 day maximum rainfalls. So looking at some of that flooding potential into the future, and then longest dry spell length, and thinking about drought within this region. Go ahead. I mentioned in one of the slides about opportunities that we have a lot of tribes in our region. And so and also the tribal consortium members, and you'll hear one of our case study presentations involve those two of the tribes in our region. So we have quite a lot of experience working directly with tribal governments on climate efforts and on research. So there are some resources available online about the ethics of working with tribes, and also it's, we are in contact with the Tribal Liaison Network for all of the CASCs, and they have additional resources. Our tribal liaisons also work directly with tribes to provide climate training to them, to do capacity building and training. There's a really large youth component, workforce development for youth and educators. And a fair amount of what we do relates to making those connections between researchers and tribal governments to get their information needs met. I mentioned the tribal liaisons. Within each of the CASCs, there is a tribal liaison generally funded through the Bureau of Indian Affairs Tribal Climate Resilience Program. There are, we also have additional staff within South Central CASC. One of our consortium members, the Chickasaw Nation, supports a tribal liaison. We have another position that's primarily focused on Western Oklahoma, and then another position in New Mexico as a tribal liaison. And I have a background working with tribes. So as the climate adaptation planner, I'm also happy to chat with people about work with tribal governments. Next slide. The climate adaptation planner role within the South Central CASC is a new position, and my role in doing that work is really to help people define, help communities and agencies and historically marginalized populations and tribes think about how they might do climate adaptation planning and how to bring equity elements into that planning process. And so this is also something that SCIP does in its direct work with communities. As Vinny mentioned, there's a person on the SCIP team who is really focused on climate equity and justice. So that's an important part also of the CASC's work. And we have these two diagrams here. They're part of our new portfolio in helping folks understand how planning works. The one on the left is about climate adaptation planning, and you can see in the center of that is the engagement process with the folks that the planning is for, and that involves communication, equity, different forms of knowledges, and prioritization. And on the right is sort of the classic vulnerability assessment process diagram, where we're bringing together exposure, sensitivity to get impact, and also then adaptive capacity to look at vulnerability. And that process, is under consideration, and there are some newer versions of that from other agencies, but that's kind of the classic model. So the emphasis of the CASC's work is partly these resources that are available, but also the different team members within South Central CASC and the ability to reach out to us and explore what your information needs might be and how we might be able to get those met. And the email for that and also the website are at the bottom of all of these slides also. Thanks.
Awesome. Thank you so much, Shannon and Vincent. Again, any questions you have, please put them in the chat and we will have time a little bit later in the session to answer those. But we want to give you all a chance to reflect and kind of discuss all that you've learned so far. So we are dropping the Jamboard in the chat, and we are going to be moving into smaller rooms and really focusing on introducing yourself first and getting to know who's in your group, and then looking at these two questions, which you will find on the first sheet of the Jamboard. Everyone is going to be using the same Jamboard, and you'll see the question right at the top of the page. So the first question is, what challenges stood out for you all? So just reflecting on what you heard so far, and then what information and tools stood out for you as well, and why, and kind of how that kind of connects to your work. So those are the two questions. Again, the Jamboard is in the chat. We will be in these rooms for about 15 minutes. When we come back together, we're going to take a break. and then come back for those two really excellent case studies. So Rachel, I believe, is making the breakout rooms, and yeah, until 1:55, we'll be in there. And I am excited to move into our next section, which is going to feature two really great case study speakers. And I will introduce our first case study speaker, which is Annie Vest from Freese and Nichols. Annie Vest is the mitigation and disaster planning lead at Freese and Nichols and the vice president of the National Hazard Mitigation Association. She currently serves as a subject matter expert to the Department of Homeland Security Resilient Investment Planning and Development Working Group. Annie is the former state hazard mitigation officer for Oklahoma. She has extensive real-world experience in hazard mitigation, pre- and post-disaster, and emergency management. As SHMO, Annie was directly responsible for $130 million in federal hazard mitigation assistance funds and the review and approval of local hazard mitigation plans. In 2016, she received the FEMA Region 6 Regional Administrators Award for streamlining hazard mitigation and hazard mitigation planning through FEMA Region 6. She has conducted the FEMA G318 Local Hazard Mitigation Planning workshop throughout Oklahoma on several occasions, and Annie was a key contributing member of the first formal FEMA Region 6 Regional Advisory Council Subcommittee for Mitigation Planning. She assisted in developing streamlined planning tools now being used throughout FEMA Region 6. She is a proven leader and is often invited to participate in policy discussions at the national level, specifically in flood buyout policy to practice. Annie assists various clients in achieving community resilience, and she holds a bachelor's in psychology and disaster management and a dual master's degree in adult and community education and executive development for the public sector. So I'm so happy to have Annie here with us and to share a little bit about herself and her case study.
Great, thank you. I will try to be brief. I don't have a slide. I think I only have about 5 minutes, so I'm gonna watch my time here. And thanks for having me. I've had the privilege of working with Skip for quite some time. Rachel Riley and others from the organization, with them being at the University of Oklahoma, they're in my backyard. I'm coming at you from Tulsa and also the reservation of the Muskogee Creek Nation. I primarily work with local governments in Oklahoma, but since joining Freese and Nichols about a year ago, I work with communities across the Southeast United States. So that ranges from small tribes in Louisiana, tribes across Oklahoma, and certainly various communities, both local and at the state government. And I also have the opportunity to work as a consultant directly to FEMA. And most of my background is in the FEMA hazard mitigation space. And I've been privileged enough over the last 14 years to see FEMA lean forward into trying to plan for future conditions as opposed to just looking historically. The Skip Simple Planning tool that was discussed earlier in the presentation is something that I'd like to think emerged a little bit from a need that was in Oklahoma. We had the first simple planning tool developed out of a necessity from local communities not understanding how to look at climate data in a way that one, they could effectively communicate to elected officials in a politically neutral type of a way, and two, that they could put into a plan and turn it into something actionable rather than having multiple different federal agencies and federal resources that were sending them in multiple different directions to receive climate data. And so where I've used the SCIP data in the past, I'd like to just talk about my experience with the city of Tulsa. It's my probably best and most significant example because I started using the SCIP Simple Planning tool in the 2019 update of the City of Tulsa Hazard Mitigation Plan. I believe that the SCIP tool was originally released back in 2018, if I'm not mistaken. And at that time, FEMA had not yet begun requiring local jurisdictions to consider climate change or future conditions and hazard mitigation planning. But I knew based on my experience at the state that it was coming because right around that time, state governments began to be required to address climate change in their state hazard mitigation plans. So when we began the update of the Tulsa Hazard Mitigation Plan, I used the SCIP Simple Planning tool to pull in from the tool itself the narrative of each hazard, each climate hazard in the plan on what could be expected in the future for that hazard. It allowed me to tiptoe in the direction to address climate change within the city of Tulsa. They had not had plans in place before that covered climate change and covered any sort of future conditions modeling. But it allowed us to talk about that in a way that it didn't come off from a private sector consultant that I was leaning left or right in one direction politically, because the University of Oklahoma and SCIP is a very reputable source of information, and it was received in a different type of a way. And so we were able to include future conditions and climate change in the Tulsa Hazard Mitigation Plan before it was required. In 2024, the FEMA mitigation planning policy has been updated and now is in effect that does require local communities to address climate change and future conditions in their hazard mitigation plan. And the tools that are provided by universities, by these different consortiums, are just a little bit easier for communities to digest. So for me as a private sector consultant, for example, rather than because I don't consider myself to be a climate expert, rather than trudging down the path of pulling in information and communicating it outwards, I rely on the sources that are in front of me. So I'm working right now on the 2024 update for the City of Tulsa's Hazard Mitigation Plan. And we, again, are using the data provided by SCIP. We've also pulled in the state climatology, or the state Oklahoma Climatological Survey, Dr. Kevin Clazel, who's also big in this space, just to, again, bring him into the conversation and be a voice from a more neutral source. If you're familiar with Oklahoma, you might be familiar that we have a pretty conservative administration at the state level right now. So it's an interesting dance when we talk about climate change, and that allows us to pull these resources in and, again, do this in a way that no matter the government that we're working with, whether it's state or local, no matter the political affiliation, we can introduce this topic or continue to build on this topic in a neutral way. And the other thing that's been very beneficial from having these data sources available is to be able to use them in federal grants. So you might think about climate adaptation planning, and you might think about getting actions locally. But one thing that the current administration at the federal level is very focused on is addressing the climate crisis at home as well. And so in FEMA grants, there's a priority right now to ensure that we're addressing climate change. And the FEMA requirements in those grants is to look at the community and show how the project links back to some sort of climate planning. Most communities in the Midwest and in rural America have not gone so far as to address climate change because it doesn't affect them as emergently as some of the other areas that we're seeing. And so it's tough because state by state, it's going to be different on if there is a climate plan in place. So rather than having an Oklahoma climate plan that we could refer back to or a Tulsa climate plan, We referred back to the University of Oklahoma and SCIP when seeking a competitive Building Resilient Infrastructure and Communities BRIC grant for the city of Tulsa. And to meet the requirement for it to address climate change, we referred back to the SCIP tool. We also turned it and said this was a flood project. Rather than just it being flood, we also knew that the information we were receiving from SCIP and also the National Climate Assessment said we would be experiencing increased days of extreme heat in the future. So we changed it into not just a flood project, but we also did a co-benefiting heat project. And while you can't quantify necessarily the benefits of reducing heat the same way you can flood, we were able to qualitatively address that in the application and back up that information using these sources. So just to boil it down, I use this in mitigation planning. I use it in any sort of community outreach when I need a data source. I use the different tools when I'm documenting qualitative cost effectiveness and communicating future conditions in different FEMA grants. And I'm very, very excited to see where these additional consortiums and groups are headed by way of providing these resources outwardly. It's just something that not every community is going to be able to access. So it's remarkable that the different universities can come together and provide these resources in this way.
Thank you so much, Andrew. That was really, wow, you packed a lot in such a short amount of time, and it was so great hearing about all of that. If you have any questions for Annie, again, you could put them in the chat, and we will have time for questions and answers for all of our speakers today. So Barney is not able to be here in person. He will be an expert witness at a trial that is currently happening. And so we have a video presentation from him, and you still have the opportunity to share any questions that you might have. So Barney Austin has worked in the field of water resources for more than 30 years. With a bachelor's degree in agricultural engineering and a PhD in civil engineering, he specializes in water supply planning, hydrology, hydraulics, and environmental flows. He has lived and worked in Canada and England and has been in the United States for the last 17 years. The former director of the Surface Water Division of the Texas Water Development Board, he was an active participant in the development of state water plans in Texas, Oklahoma, and California, and oversaw 9 surface water programs. Barney has managed many large projects and diverse groups of people, successfully bridging the gap between technical and non-technical stakeholders as well as the private and public sectors. He now heads up Aqua Strategies, Inc.
Hello, everyone. This is Barney Austin, and I've been asked to spend a few minutes talking about our Red River project and what interesting things have come out of it. So most of you know about the project itself. What we were, perhaps you don't know a little bit about the origin of it. Back in 2014 or so, it was the end of a pretty long drought, and Lake Texoma was seemingly almost empty. And then a few months later, it was as full as it's ever been. And that was a pretty dramatic turnaround. And people were wondering at the time whether that was climate change. So we had this study funded by the Climate Science Center, as it was called at the time. And it involved choosing 3 global climate models and 3 RCPs and 3 different downscaling methods, such that we had 27 different climate model data sets, and running those data sets through some rainfall runoff models and in turn water availability models, with the ultimate goal of trying to figure out how much uncertainty we had in future water availability across the region. And one of the outputs from our modeling exercise were these models themselves and the data associated with them, and the water availability models that I'm going to talk about a little bit later. But the model that was used for determining rainfall runoff and ultimately impacts of climate change was a VIC model, It's an energy balance model, but it's essentially a rainfall runoff model, and we had a gridded data set for the entire watershed. And then we fed that information into a water availability model, in this case, Riverware, for determining impacts to water rights and overall water availability across the entire basin. And we, as you can see in this figure, we looked at the entire Red River Basin, all the way from the headwaters in New Mexico all the way to its where it joins the Red River. Sorry, where it joins the Mississippi River in Louisiana. And the output, and we had a whole bunch of figures like this in our report, the output looks something like this, where we show that some parts of the watershed are getting drier, or expected to get drier in the future, and some parts of the watershed are expected to get wetter, and the size of the dots there gives us some sort of sense on how tight that cluster of outputs is for that particular result. So the main thrust of this, now I know I only have 10 minutes, but was to talk a little bit with you about what other stuff has come out, what other research, what other interest has there been in the study since we completed it. And probably the first thing that we did was get a second phase of work funded. The model results were super interesting, but there's lots of questions that came out of the report, obviously, one of which was, what are the impacts on the aquatic environment? And so we teamed up with Shannon Brewer, who unfortunately is no longer with us here in Oklahoma, but she was interested in seeing if you could see fish traits in certain species to determine how vulnerable they are to drought. So that was kind of an interesting study. And then we also refined the Riverware model that we have for identifying vulnerable communities across that whole area. What's interesting is that the refinement part, the phase 2 of the work, identified some communities that appeared to us to be super vulnerable, climate change or otherwise. It looked like they were about to run out of water, and Tishomingo was one of those places. And so we worked with them to identify an additional source of water. They were sole source on Pennington Creek, and Pennington Creek has been gradually getting drier over time, and the severity of the drought's really being felt there. And so the Chickasaw Nation has worked with a landowner nearby to develop some groundwater to supplement their supply. And actually, in this short period of time, they've already tapped into that water, and they've needed it as Tishomingo has grown and the flows in Pennington Creek have reduced. Another application, another thing we've done with some of the modeling and models themselves is take a look at the Blue River. And this Riverware model supported the development of an economic study showing how critically important it is to maintain reliable flows. And this is an initiative between the state and the tribes to look into protection mechanisms for the Blue River to protect that valuable economic resource. Another thing we did with the Riverware model, and this is a Riverware model for the entire Red River, but ultimately we broke up certain parts of the river basin into smaller pieces so we could do some more refinement. But a water right application came in the Kiamichi River, a large one. And so we used this model to an existing water right holders. Ultimately that permit application was withdrawn, but it was a super useful tool for determining the hydrologic impacts that permit might cause in the basin. More recently, we've received, when I say we, Choctaws and Chickasaws have received funding from the U.S. Army Corps of Engineers to look into supply and demand issues in south central Oklahoma on the north side of Lake Texoma. And the Riverware model was used to demonstrate that there really isn't any additional surface water available for appropriation in that basin other than from Lake Texoma, where there's abundant water, except it has high salinity. So we're looking into a sort of a regional assessment of both groundwater and surface water availability across the region to develop viable water management strategies for the future using the Riverware model and the Red River model results. Even more recently than that, the Choctaw and Chickasaws have recently funded the development of, I guess, further refinement of this Riverware model for help in the water settlement. And some of you may know that the Choctaw and Chickasaw jurisdictional area was split up into A, B, and C basins for determining Choctaw or Chickasaw involvement in future water right application discussions. And these B basins, which are identified as the most important ones, those are the ones in green, are the ones where these refined Riverware models are being used right now. And for context, the state of Oklahoma makes decisions on water right applications based on the average annual flow. So it's important to have a more sophisticated model in order to make good decisions or be able to have better information when those decisions are made. The terminology in the water settlement is an adequate hydrologic model, and we're working with the state of Oklahoma on these models to help ensure that these are the models that would be used for these water settlement discussions in the future. But, you know, that's a lot of I've been talking about a lot of the models and the data that's come out of these models from the Red River study, but there's actually a lot of other work that's going on as well, and we don't have time within that 10 minutes, but we're doing a water reliability study for Durant, Oklahoma, based on this refined Riverware model. We looked at Sardis and Hugo reservoirs, potentially doing flood reallocation in those reservoirs using the same model. There's at least 6 that I can recall other studies ongoing that are either using the data or using our models or in some way referring to the work that we've done on their own studies. I've been approached by 6 different researchers that I can recall for work on that. And I think due in part to the success of the Red River study, we were able to get funded a very similar study on the Canadian rivers. So essentially we're using that same methodology, using those same VIC models and Riverware models, but applying all of that to the Canadian River. So there's a piece of work that's about to wrap up on that particular basin, which is just to the north of the Red River Basin. And I understand that the Kaw Nation are also interested in doing something very similar for their watershed and for Kaw Lake. These results are being presented at lots of different conferences, and there's lots of different memos and reports, not all of which are in the public domain, but unfortunately there aren't very many published papers, and we are going to try to change that for the Canadian River study and produce at least one paper, so it'll be out there and potentially more accessible to researchers, or at least make it so that more researchers are available and aware of this study. Trying to keep it within those 10 minutes, so I think I'm out of time. Again, if you're watching this video, Frank Shala should be available to answer questions. And if not, feel free to follow up with me. My contact details are up there. Or Andrea Ablett with the Choctaw Nation, or Nawakis Weber with the Chickasaw Nation. And they're both very aware of that study and could answer any questions as well. So thanks for your time, and look forward to speaking with you further about this.
And I believe we do have a few questions that have come in already. Okay, yeah, we do have a few questions for our instructors, Vincent and Sharon as well. And if you have any questions for the case study speakers, again, you can put them in the chat, but we do have 2 questions for Vincent that I wanted to get to. One is from Whitney Gray. And the question is, how were the simulation results, Harvey happens in Orleans Parish used? And I know you kind of touched on that in the chat, but Vincent, did you have anything else that you wanted to share for that?
Yeah, perfect. So as I mentioned, basically we teamed up with the Sewage and Water Board of New Orleans and their engineering firm, which is Ardura, and we're all sort of working together. So we're on the rainfall side. Ardura is doing the hydrologic modeling, and what we did, and make sure I'm answering the right question, right? Or am I not answering the question? Sorry, I was looking at a different one here. Is this the policy one?
Yeah. The was that applied in a planning study or
Okay, yeah, sorry.
exercise? Did
So
any new policy result?
I was reading a different question here and I was talking and I was like, oh, I'm confused. But no, okay, yeah. So we took that, we again we provided the 5-minute 1 square kilometer grids. They had done all this extensive modeling in New Orleans at the street level. I mean, they had a really high resolution model with, and I forget the term, you know, all these little intersections of the stormwater and how sometimes the debris can get up, so it'll lessen, you know, the speed at which the water runs off, and sometimes it'll backflow and all that stuff. So they took our rainfall information, put it into those models, and they ran all these different scenarios. For example, what if our pipes in our drainage, our stormwater was working at 100%? What if it was working at 5%? You know, and everywhere in between to see sort of where flooding would occur, what streets, and what areas of the city would have the most problems. And right now we're sort of compiling the results. I know the Water Institute of the Gulf is building some sort of web interface where you can actually go in and play around with what if they were working at 100%? What if they were working at whatever, and you can visualize sort of what would have happened. And again, we're working on a paper regarding that, and again, hopefully, the Sewage and Water Board and their engineering firm will sort of listen to what we're saying, and at least prioritize some areas in the city with regards to the street flooding and stuff that can be improved.
Awesome. Thank you. And then one question for Vincent from Carlo. Has Skip developed climate data tools for projections of return periods for extreme climate events, such as extreme precipitation for different future emission scenarios?
Yeah, so I mean, we do not have any current tools that do that. I guess the current tools that do exist for that are it's me and my colleagues here at Skip. For example, we had a project working with some oyster aquaculture folks, and we've had projects looking at crawfish actually in Louisiana. And what we did was we went and downloaded a suite of the CMIP-6 models for certain variables, some of the higher resolution climate models, and we estimated what may happen in the future using those models. But we don't have a tool that does that, that does that per se. But I think the CASC has a lot of those projections. The only thing that I run into a lot when I talk to stakeholders in different communities is they often want sort of these unique data sets that aren't readily available. So that's where we come in. You know, if somebody comes to me and says, "Can you give me projection of this certain area for 2050?" I can go in and download the CMIP-6 model, and I can do that myself. But to answer your question more directly, no, we don't have any tools that do that just yet. Maybe on the horizon, though. We'll see.
All right. And we have a question for Frank about that wonderful case study that Barney recorded for us from Pahlavi. So curious how the partnerships with the indigenous tribes came about. What was the governance structure that led to the development of the model and other projects that came after that?
Yes, that's a good question. So Barney Austin, he transitioned from the Texas Water Development Board into private consulting and started working in that area and on projects for some of the tribes covering the Red River Basin. And so that that started growing kind of their relationship and different opportunities for collaboration. And then it started spreading into kind of how we can work together to support applications for funding for them, that like the CASC funding opportunities, or the Bureau of Indian Affairs kind of funding opportunities, or even BOR opportunities. And so we've worked with them in trying to understand their needs, and not just their needs as a tribal nation, but also individual community needs as well, and targeting kind of funding opportunities through those mechanisms. And the model itself for the Red River study came about as an opportunity that they had identified for wanting to better understand their territories and the impacts of climate change. And so we were able to work with them and work on the project through them. I hope that answered the question, but if not, please clarify.
And I just want to chime in also that the Chickasaw Nation and the Choctaw Nation are members of the South Central CASC Consortium. And as members of that consortium, they're very much aware of the work the CASC does and the funding that is available through USGS for research projects like this. So one of the things that we at the CASC are interested in doing, and one of the reasons we're here sharing all this with you today, is so that more people are aware of this as a possible resource. In this case, because of the consortium membership, that makes it easier to fund a particular project like this. But there are also opportunities to work with other research teams, in different universities and through different consortium members that can help support the tribal projects like this one. And Pallavi, there was a second part, which I think Frank might be better positioned to answer, about other stakeholders that were involved in the formulation of the model and the projects thereafter.
Yes, a good follow-up question. So the initial Red River studies were a collaboration with climate scientists at University of Oklahoma that are also associated with the South Central CASC. So that we work closely with them in developing the GCMs and the outputs that we then used to build those rainfall runoff models, and then used to input into those water availability models that we were talking about, that allows us to study the impacts of individual water rights and reservoirs. In addition to the climate scientists that we work closely with, in the more recent Canadian River project that we're working on is nearly complete. We've collaborated with the Oklahoma Water Resources Board. They're an important partner to the tribes, especially in regards to the water settlement. We want to make sure that as we're developing these models, we're wanting to make sure that they align with their methodology and their vision for assessing kind of new permit applications, as it's tied very closely with the water settlement, and they're wanting to be able to use these models to be able to implement the water settlement. And so Oklahoma Water Resources Board staff were able to participate and contribute really valuable information regarding future water use projections that they develop as part of their Oklahoma Comprehensive Water Plan, as well as other tools that they use. And so they've worked closely with us just recently. And I believe they're wanting to look at other opportunities to collaborate as well on other future projects. They were involved in the Blue River Economic Study as well. I think those are the main partners that we've collaborated with, but I'm sure I'm missing some.
Can I maybe mention from the tribal side, just for context for anyone that's not in Oklahoma, that when these projects are benefiting the Chickasaw or the Choctaw, they're actually benefiting a good just geographic portion of Oklahoma in general because of the way that the reservations are. So the reservation, for example, of the Muskogee Creek Nation is the landmass the size of the state of New Jersey, and certainly covers the incorporated jurisdictions and counties within the state. So a lot of these other communities, especially down in the Blue River and down towards Texoma and other areas, they would not, without something of this magnitude, a collaboration with the tribal governments, be able to ever do this on their own. They're very disadvantaged, very impoverished in that southeast portion of our state. And so we're a little bit backwards in Oklahoma, where oftentimes our tribal governments step up and do quite a bit more than our local communities would be able to provide for themselves. So really excellent work, guys.
Yes, thank you for that additional context, Annie. I believe it's that both the Chickasaw Nation and Choctaw Nation cover over 22 counties, and I think around 500,000 at least in population. So we are talking about quite a large area, and also reinforces kind of their support for those local communities and concerns for the future climate conditions and its impacts.
Amazing. Well, thank you so much, everyone, especially Annie and Frank, for answering the questions, even though you didn't give the presentation. Thank you for being here. I do want to move us to our next activity, just to give you all a chance to reflect and think about these two questions. So we are going to be moving back into smaller groups and focusing on these two questions. So what data service, modeling, or technical tools do you currently use, or do you see enhancing the work that you and your company does? And then what specific information or input do or would you need from your clients to inform or customize the use of climate data and information in your products and services? So the Jamboard, the link is the same, but that's being put in the chat. You're going to be looking at the questions on page 2 and 3. But if you didn't quite make it to questions on the first page, feel free to go back and kind of reflect on that again. So we're going to be going into smaller groups again, and we'll be in these rooms until 5 before the hour again, and then we'll wrap it up together and close it out. Thank you again. Well, thank you. Thank you again, everybody, for being here. To our instructors, Vincent and Sharon, and our case study presenters, Annie and Barney / Frank in person here. I know that our group really enjoyed them, so really appreciative of that. Just a couple things again before we go. As always, don't forget to sign up for those one-on-one consultations and connect on Slack if you're interested in getting reminders or if you'd like to stay in touch between sessions. And then we have our next session, which is it already the last of our regional sessions? Time flies when you're having fun. So our last regional session for the North and Mid-Atlantic this Thursday, again 1 to 3 p.m. ET. That will be our last regional session, I guess, but then we'll all come back together for our final closing session. Thank you again, everybody, for being here and just for a great session today. If you have any questions that you wanted to ask the instructor or speaker, definitely feel free to share them and we can connect them to the right person.